In this video, we're going to look at a basic introduction to the graphs of trigonometric functions. We've met three trig ratios in previous videos. We've seen that the sine of an angle, sine x or sine theta, is given as the opposite over the hypotenuse. We've seen that cosine x or cos x or even cos theta is given as the adjacent over the hypotenuse. And we've seen that tan x or tangent x is given as the opposite over the adjacent. Each of these has their own specific graphs. In the video, we're going to focus on now the graph of y is equal to sine x and the graph of y is equal to cos x, and then we will look at solving some equations. We will consider tan x in a later video. So let's start off. We're asked to sketch the graph of y is equal to sine x for x between 0 and 360 degrees. So we're sketching this. We're not plotting it. This is just a freehand sketch. What we need to ensure is that we have the key features on and the general shape of the curve. What I'm going to do is quickly sketch this, and then we will put some points on. We start at 0 with a value of 0. We come up to a maximum value of 1 at 90 degrees. We then come back down at 180 degrees with a value of 0. We come down to a minimum value of -1 at 270 degrees, and then we come back up to 360 degrees where the value is 0. This is x, this is y, and we have now y is equal to sine x for x between 0 and 360 degrees. So this is the maximum value of 1, we have a minimum value of -1. Sine x can never be greater than 1 or less than -1. I'm going to put this point on here. This will be 0, 0. We've got 180, 0 and 360, 0. We have this point right here, and this is going to be 90 degrees, and our first maximum is 90, 1. This is going to be 270 degrees, and our first minimum here is going to be at 270, -1. This graph cycles every 360 degrees. So 360 degrees on, it will look exactly the same. 360 degrees in the opposite direction, it will look exactly the same. It cycles infinitely in both directions. So if I just put that on, it'll come round and it'll look something like so. So this now is the general shape of the curve, and these are the important features. What I'm going to write now is one massive result that we can use. We can write now that the sine of x will be equal to the sine of 180 minus x. This is telling me that we have an axis of symmetry. If we look at that, that will occur just here. So I'm going to put that point on. So what I'm going to do is solve an equation, and we're going to look at how we can use this property to find certain values. I'm going to say now that the sine of x is equal to 1/2, and we want to solve this equation for x between 0 and 360 degrees. So if I drew a line now, we could see that at 1/2 there are going to be two solutions. We've got one solution, and I'll put it just here, at this point right here. I'm going to have the next solution just here. Whatever my principal value, which is what we call it, is, we can simply subtract that answer from 180 to get the other solution. This is going to give me one angle. This will give me now that angle subtracted from 180 degrees. So to solve this equation, we can find what we call a principal value. You don't have to use that terminology, but it might be something that you wanted to do. So we're going to take the inverse sine of both sides of the equation. This gives me a special angle, and this gives me 30 degrees. If you want to check that on a calculator, make sure you're in degrees mode, shift mode 3, and that will give us the little d for degrees. We take the inverse, or sine to the -1, of 1/2, and that gives us 30 degrees. What we can say then is the following: therefore, by symmetry, x is going to be equal to 180 degrees minus the 30 degrees. So we have our next solution at 150 degrees. So we have two solutions. Here we have x is equal to 30, and here we have 180 minus 30, which is 150. All other solutions will be plus or minus 360 degrees on. So what we can say is that the sine of x will be equal to the sine of x, and then we're going to have plus or minus multiples of 360 degrees. That kind of makes sense. If we think about this now, if I wanted to go to the next one, we can see the next one is going to be here, and all I've done is jumped from this point right here to this point by adding 360. I can jump from this one to the next one by adding 360, and by the same token I can subtract multiples from there. So that is a massive feature that we should hopefully be able to spot and use. So we find one, and then by symmetry we find the next one. So we say that this cycles or has a period of 360 degrees. We've looked at the maximum value, we've looked at the minimum value in this interval, and we looked at what we call the zeros. Okay, let's now look at the cosine curve. The cosine curve is very similar to the sine curve. So what I'm going to do is just go ahead and draw the sine curve, and we're going to translate this. So in later videos we will look at using graph transformations, but hopefully now what you'll see is if I take the sine curve, we can simply move this backwards or forwards by 90 degrees. So I'm going to now translate this, so let's go ahead and move it back by 90 degrees. So at this stage I'm now going to just take the cosine curve and take it back up to a maximum, and that will be just here. So what we've got this time is the following. Let's just take this off. We have now our value here. We have again a maximum value of 1 and a minimum value of -1. So this is 1, this is -1. This is going to be y, this is going to be x, and this is a graph of y is equal to cos x from 0 to 360. So we have this point right here. This is going to be 0. So our first maximum is 0, 1. We then have our first 0, which is at 90, 0. We have 180, and this is our first minimum, or first positive minimum, 180, -1. We have another 0 at 270, and then we have this point right here, which is 360, and that now gives us a maximum of 360, 1. If we just look at this now, and I'll just switch away from this for a moment, we can say that the sine of x is equal to the cos of 90 minus x. We can also say that cos x is just a basic graph transformation, it's the sine of 90 minus x. If you'd like to see that in a sort of a practical approach, what we could do is now grab up a little triangle. So let's say that we've got this now, and we'll put on, let's put that this one is A, let's put that this is B, and let's put that this is C. We'll say that this is going to be the angle x, that's a right angle, and this is going to be 90 minus x. So I've got this angle of 90 minus x. So if I write down now sine x, well, sine of x is going to be the opposite over the hypotenuse, which gives us A over C. If I look at the cos of 90 minus x, well, that is the adjacent over the hypotenuse, which is going to give us A over C. So we can see therefore now that sine x, so this is quite a practical, a nice little practical way of showing it, is cos of 90 minus x, and of course we could do exactly the same to show the other. So if you're unsure, we could use that property if you were struggling to draw this. Okay, so let's say we needed to solve an equation, and I'll pick a nice straightforward one again. Let's say we wanted to solve cos x was equal to, again, we'll take 1/2. The reason I'm choosing 1/2 is because I know the value of that, and over time you'll come on to what we call exact values. Now if we look at that, and I wanted to find that value between 0 and 360, that's going to be about there. Now that tells me that I've got two solutions. I've got one solution just here, and then I've got one solution just here. We've got now an axis of symmetry, and the axis of symmetry this time is going to be now at 180 degrees. As a result, what we can say, and this is an important result, is that cos of our angle, which we've got as x, will be equal to cos of 360 minus x. So if I can find a value just here, then all I'm going to do is subtract that value from 360 to get this one. So let's go ahead now and solve this equation. So principal value, x is going to be equal to the inverse cosine, so inverse cosine now of 1/2. Again, this is going to give me a special angle, and that is 60 degrees. If you're unsure, which you, quite clearly at this stage is reasonable, inverse cosine of 1/2, and that's going to give us 60 degrees. So I can say that this one is going to be 60, and it would have the y coordinate of 1/2. So by symmetry, what I can do is go ahead and find the next one. So I can say that, therefore, x is going to be now 360 minus the 60 degrees, which is going to give us that x will be equal to 300 degrees. So if we look at that, I found 1, and by symmetry, I'm simply going to subtract that from 360. So that will give us 300, 1/2. So that's what we could use. And again, with the cosine curve, it cycles every 360 degrees. So if we have one solution, cos x, we can say that this will be equal to cos of x plus or minus multiples of 360 degrees. And I've put n there again. N just means if n was 1, then we'd add 360. If n was 2, we'd add 720. If n was -1, we would subtract that. And if we just extend this on, let's just extend this on. Extending it on, it will go something like this, down, round, and like so. This is not brilliant, but we can see that this one right here, what I'm going to do is jump from here to here. I'm going to jump from there and just add multiples of 360 degrees. So they're the important parts. We've got a maximum at 0, 1, a minimum at 180 degrees of -1. We've got our next maximum at 360, 1, and our zeros are at now 90 and 270 in this particular interval. It's going to repeat, and we're going to see it repeating every 360 degrees. So let's look at this graph in action. Here is sine x. So with this one, if we scrolled across, we can see it's going to go infinitely in this direction, and we can just move it back. We can see we've got a maximum value of 1, minimum value of -1. These now are in degrees, so one full cycle from here to here, 360, another full cycle to 720, another one to 1080, and so on and so forth. If we introduce cos x is simply a phase shift of 90 degrees, either forwards or backwards, maximum 0, 1, we've got 90 at this stage, we've got 180, we've got 270, and we've got 360. So that gives us a rough idea of what they look like. I'll just put tan x on here, we'll look at this in a later video. Tan x looks something like so. So there we go, these are our 3 basic major trig functions. Okay, so let's go ahead and get back to these. So what we're going to do is go ahead and solve some equations. So we're asked to find all the solutions in the interval for theta between 0 and 360 for. So sine theta is equal to 0.4. What I'm going to do is just quickly draw a sketch. Sketching might help you out. I'm not suggesting it will, but it might give you some idea. So we know with the sine curve that we're going to have one solution theta degrees in, or x degrees in, and the same value we're going to have now theta degrees or x degrees back from 180 degrees. So if I look at 0.4, 0.4 is going to be about here. So what I'm going to have is the first one, and we can put this on, this one is going to be theta, so that's going to be my principal value, and then this one is going to be 180 minus theta. We can see there are no other solutions in that interval. We've got a maximum of 1 here, that's about 0.4, so we're just going to have this one, and we're going to have this one. All others would be multiples of 360 degrees on. So let's start off. What I'm going to do is write the principal value, PV. Don't need to do that if you don't want. We can say that theta will be equal to the inverse sine of 0.4. We're going to need the calculator for this one because it's not a pretty number. And if we do now shift sine, inverse sine of 0.4, That's going to give me now 23.57 and so on and so forth. So we'll say now that that's 23.6 degrees to 1 dp. So that's located that one, that's theta just here. So therefore now the next one, theta is going to be equal to 180 minus the 23 point ... that I have in the calculator. If you want to store this in the calculator, shift store A just in case, entirely up to you. So all I'm going to do is 180 minus my answer, or if I wanted, minus A, and that's going to give us the 156.4 as we expected. So theta is equal to 156.4 degrees 1 dp. Quite clearly, both of these added together are going to give us the 180 as we would expect. So those are the solutions for sine theta is equal to 0.4 in that interval. Okay, let's look at the next one. Cos theta is equal to 0.71. So what we'll do is a quick sketch, and let's just straighten that up a little. So a quick sketch of the graph. We're going to have two solutions in the interval, so let's go ahead and do those. So this one, we're going to come down. This is a cosine curve. We come back up, and it looks something like that. So we want to know where this is going to be 0.71. So that's the value of y. 0.71 looks to be about there. So if we just jot this up, this, remember, is the axis with our angle theta on, and this is going to be now y. So I want one just here, so I'm going to have now our principal value of theta, so that's 0.71, and then this one by symmetry with the cosine curve is going to be 360 minus our theta. We know that this is symmetric about the line of 180 degrees. So it's symmetric about there, whereas the sine curve was symmetric about 90. And we looked at that on that particular graph. So let's go ahead, let's go and solve that one. So we'll do that. We'll say now that principal value, so PV, principal value, theta is going to be equal to the inverse cosine now of 0.71. I don't know that, so I'm going to use the calculator. Shift cos, inverse cosine, cosine to the negative 1 of 0.71. Principal value 44.76, so let's write that in. So theta 44.76, so we'll say 44.8 degrees to 1 dp. That is us just there, that is our 44.8 degrees. Therefore this one right here is simply going to be 360 minus that. So we can say theta is equal to 360 minus the 44 point ... In the calculator, 360 minus my answer, and that gives me 315.2. So 315, as we would expect, 315.2, and that now again is to 1 dp. So 1 dp. So we got those two solutions in the interval. All others will be plus or minus 360 degrees on. So that now solves that equation. If we look at the next one, 3 sine theta minus 2 is equal to negative 1.3. If I ask you to solve the equation 3x minus 2 is equal to negative 1.3, you'd add 2 to both sides, which would give us 3x is equal to 0.7, and we divide by the 3. 0.7 divided by 3. We do exactly the same here. We're simply now getting an equation that says sine theta is equal to some number. Remember, sine theta, it should give you some hint that you can't solve this as just by taking the inverse, because sine theta can never be negative 1.3. It can be less equal to or less than 1, yet in turn has to be greater than or equal to negative 1. So all I would do right here is write that 3 sine theta minus 2 is equal to negative 1.3. So adding 2 to both sides, 3 sine theta is equal to 0.7, and sine theta is going to be equal to 0.7 over 3. So what we need to do now is get a principal value. Principal value theta is going to be equal to the inverse sine of 0.7 divided by 3. If we go back to our curve, our sine curve, let's just go ahead and draw this. With our sine curve, we can now state that whichever value I get, we can take that away from 180. So if I put this on, we're looking at a pretty small number here. So it's going to look something like that. Let's just move that into place. It will do something like this. So what we're looking at is 0.7 divided by 3. which is what, 0.23, something along those lines, so 0.7 divided by 3. So let's go ahead and find the principal value. So we'll do shift sign of 0.7 divided by 3. Principal value 13.5, so theta is equal to 13.5 degrees, 1 dp. So that one is just here, so that's our 13.5. Therefore, this is going to be the 180 minus the 13.5 or 13 point whatever it is in the calculator. So 180 minus that quantity, so minus that 166.5. So theta is equal to 166.5 as we expected, 1 dp. So that gives us what we have. Two solutions in the interval from 0 to 360. All subsequent solutions would be plus or minus 360 degrees on. So this one would give us now, what's that going to give us? 373.5, and then we'll be adding now to that, so what that gives 426, and so on and so forth. So there we go, that's what we've got. Nice and logical, nice graph sketching, and we can use those graphs to find the values. So there we go. In other videos, I've looked at the tan curve and also something called the unit circle or cast diagram, and you might want to refer to those, but generally speaking, this should be adequate for you to get started. So a video on the graphs of basic trigonometric functions.